Hi students, our study is about similitude. Similitude, like other transformation, it has its own characteristic. It has a ratio k, and it has an angle alpha. So similitude, you have center omega, ratio k, and angle alpha. And it's a composite of a homotopy and a rotation. If the homotopy and rotation, they have the same center, as you can see here, omega and omega. So in that case, h rho r is the same as r rho h. You're going to have a similitude having the same center omega, that of h and r, ratio k of the homotopy, and angle alpha of the rotation. However, if h and r, they have different centers omega prime, you're going to have a similitude with different center omega, and but the same ratio k of homotopy and the same angle. And in that case, h rho r is not the same as r rho h. In r rho h, you're going to have another similitude, same ratio k and same angle alpha, but different also center omega. If you have a similitude of center omega, ratio k, and angle alpha, so if you have a point M, will give you M prime. So directly, gamma M prime equal k, gamma M prime equal k gamma M, and angle between gamma M and gamma M prime equal to alpha. Okay, and if you look at this picture, here I have a homotopy of center omega. If you have a point M, if you rotate to a point M1, then do dilation, you're going to do M prime. And if you do, first of all, dilation first, and then the angle alpha, you can see that these two are the same. So that's why h rho r is the same as r rho h. Here in similitude, we don't put vectors. Why we don't put vectors like this? Because gamma m prime and gamma m prime gamma m are not on the same line. So we put only vector in homotopy. We don't put in similitude. So complex form of a similitude, z prime equal k e I alpha z plus b. It's a combination of rotation and dilation, where z gamma equal b over 1 minus k e I alpha. Now I want to prove that if you have s of a equal a prime and s of b equal b prime, so a prime b prime equal k a b, and angle between a b and a prime b prime equal alpha. So if s of a equal a prime, so z a prime equal k e I alpha z a plus b, and same for z b prime. So if you do this ratio here, you're going to get this expression minus that expression. So b and minus b cancel out. You can put k e I alpha in factor. So z a minus z b up and down will be cancelled. So I have k e I alpha. It means that a prime b prime equal k a b, what I want to show. And the angle between a b and a prime b prime will be angle alpha. The inverse of a similitude is the same center gamma but omega, but instead of k 1 over k, instead of alpha you have minus 1 of minus alpha. So in that case, s rho s inverse of any point A is equal to A, the same point. And if you do s inverse rho sa, it is also the same. Parallel similitude preserve orthogonality, collinearity, midpoints, oriented angle, ratios of length, like we did in rotation and homotopy. Now, application, here you're going to show if R and H, they have the same center. For example, I plus 1, the similitude will have the same center, and R rho H is the same as H rho R. So let us start by R rho H. So first of all, homotopy 2 I plus 1, you're going to get z prime equal to z plus I plus 1 into 1 minus 2, which is minus 1 minus I. And the composite of rotation, z double prime will be I z prime plus 2. If you multiply I plus 1 by 1 minus I, you're going to get plus 2. If you replace z prime by its value here, you're going to have here, this is the rotation, similitude. And if you want to find the center, minus I plus 3 over 1 minus 2I, you're going to have 1 plus I, the same as the homotopy and the rotation. If you do the vice versa, H rho R, you can follow here by yourself, you're going to have the same. So nothing is going to change. So that's why R rho H is equal H rho R. You have the similitude of the same center that you have it for these two, which is I plus 1 in both. Okay, the same angle and same ratio. So we can conclude that if R and H have the same center, so the similitude will have the same center. And the image of a circle of center minus 2, 3, we can replace here the new center to find its image. So you're going to get 2i into minus 2 plus 3i minus I plus 3. You're going to have the new center I prime. And like we did in dilation, the new radius equal absolute value k, which is 2. Here 2 times 4 is 8. So it's a circle of center I prime minus 3, 5, and ratio and radius equal to 8. Here, example where rotation and homotopy, they have different center. You're going to see R rho H is not the same as H rho R. So let us take here this example. So here if you do R rho H, so we're going to start first by H, 2 gamma omega 3 0. So you have Z prime equal to Z minus 3. Then if you apply the rotation, you're going to have Z double prime equal IZ plus I plus 1 into I into 1 minus I. You're going to get I plus 1. If you replace that prime here, you're going to have Z double prime is this one, and the center here, if you do it, it's 1. So I have this similitude. If you do the vice versa, R rho H, you're going to have the same angle certainly, and the same ratio, but you can see that gamma and gamma prime are not the same. So that's why if R and H have different center, we're going to have a similitude, but the similitude will have different center, and H rho R is not the same as R rho H. Now we're going to go to some application and important for problem solving. If S of AB equal A prime B prime, so here suppose you have two lines AB and A prime B prime, and both they intersect AB and CD, and both they intersect in a point O. And suppose you have the image of this AB, for example, is A prime B prime, and the image of CD is C prime D prime. Certainly here they're going to have the same angle. The same angle that you have here, you're going to have it here because it preserves angles. So if S of O, and if they intersect here in O prime, you're going to have S of O equal O prime. Sometimes we need it where, when you want to find the image of a point, before they're going to give you find the image of line AB, you're going to get A prime B prime. Then part B, find the image of CD, you're going to get C prime D prime. Then find the image of and you have the point O at the intersection of these two lines. So find S of O. S of O will be the intersection of A prime B prime C prime D prime. So we use it a lot in problems. Another thing we use in problems, suppose what they given was I have a similitude of center H. Here I have angle pi and ratio k. When you have angle pi, this is we can say it can be a homotopy H prime of center H, but instead of k minus k, you know that pi will give you minus 1. So, and suppose in the given they have also a homotopy of the same center, that of S, but I have different ratio k prime, and they told, and we can show that if we have point A, if you use S of A here, it means H prime of A, and if you do H of A, you're going to have the same point. So directly in that case, the similitude and H will be the same. They are equal, and this K will be equal my K prime, and K prime it will be minus K. Proof. If S of A equal to B, here this is a homotopy, so directly this is H of B equal minus K H of A. And if you use that of H, and if H of A come in, since they are equal, S of A and H of A, and it's equal to B, so directly H of B here equal K prime H of A. So since these two are in that case, if HB equal minus K HA and HB equal K prime H of A, so directly K and K equal minus K prime and S equal to H. And more, this is somehow similar to 1. If S of AB equal to line D and S of BC a line D prime, and you can see that B is in AB and AC, so directly S of B will belong to the intersection between the lines. So you continue the line here and it will belong to the intersection. So here we can say that here I have the S of B, this point of intersection will be S of B. So that's it concerning the similitude. So we can go now to problem practicing.